Hello everyone, welcome in our online series for Geotechnical Engineering. I am Professor Siddhi Borade from Vishwabharati Academy's College of Engineering, Ahilyanagar. In this series, we are studying about geotechnical engineering. The first lecture of geotechnical engineering is the Introduction to Geotechnical Engineering. Firstly, we have studied about what is geotechnical engineering. Geotechnical engineering is a field in civil engineering concerned with behavior of soil and rock. It means we have studied about behavior of soil and rock. Firstly, geotechnical engineering is divided, or the main components or the main part of geotechnical engineering is soil and rock mechanics, and second part is engineered system. In soil and rock mechanics, we are studying or what is soil and rock mechanics in geotechnical engineering is, in this field, the focus on the physical and mechanical properties of soil and rock formation. In geotechnical engineering, the first part is soil and rock mechanics, and this part or this system is a physical and mechanical properties of soil and rock formation. It's about understanding how this earth material behave under various load and stresses, and all the things about soil, their physical and mechanical properties are involved in geotechnical engineering. But what is the main purpose or main work of engineer in geotechnical engineering is the geotechnical engineer ensure that structure like building, bridges, tunnels, and dams are built on stable ground, considering the interaction between structure and underlying soil. The main aim or the main work of the engineer in geotechnical engineering. These two are the main part or the main components of geotechnical engineering. First, we are studying geotechnical engineering and its main component. Next part or key concept are used. Various key concepts are used in geotechnical engineering. There are 5 key concepts, or in other word, we also find or we also understand what is engineering or what is geotechnical engineering. There are 5 main components. First components of geotechnical engineering is soil mechanics. Second is rock mechanics. Third, foundation engineering. Fourth, slope stability. And fifth one is earthquake engineering. These are the main key concept in geotechnical engineering. In geotechnical engineering, we are studying about soil and rock behavior. And firstly, we have seen soil mechanics. So what is soil mechanics? The definitions are seen in this slide. The firstly, we have seen soil mechanics. This branch investigate the composition, property, and the behavior of soil, including its strength, stability, and permeability. In soil mechanics, we are studying or investigate the composition, which type of composition of soil is investigated in soil mechanics. The next one is a properties of that soil, then behavior of soil, and including the strength and compressibility and the permeability of the soil. This is called as the soil mechanics. Next one is rock mechanics. In first slide, we have seen the main components of geotechnical engineering are the soil and rock mechanics and engineered system. And the next one is the components. The next component is the rock mechanics. The rock mechanics, what is rock mechanics? The definition is here. Rock mechanics is this is the branch focused on the properties, behavior and stability of rock mechanics, of rock masses. It means it is focused on the finding out the behavior and stability of rock masses and analyze their strength, deformation and fracture behavior. In soil mechanics, we are finding or we are investigate the composition and properties of soil, and in rock mechanics we are focused on properties and behavior of the rock. This is the difference between the soil mechanics and rock mechanics. The next key component or next branch of geotechnical engineering is foundation engineering. In this foundation engineering, we are studying about the foundation design and their safety, their load distribution, their importance of foundation designing. In another word, we also define the foundation engineering is this is the branch design foundation of for structures, ensure they can safely support the weight and load they will bear. It means in foundation engineering, we are designing the foundation for structure and ensure the safely support the weight, which weight, the total weight of the structure which is gained by foundation, and the design or safe design of foundation is done in foundation engineering, and the foundation is the main part of the structure in civil engineering. So these are the first three key components or key concepts of geotechnical engineering. Then next one is slope stability. In slope stability, we are defined the slope stability as this is the branch analyze the stability of the slope including natural hillsides and engineered slopes to prevent landslide and erosion. In slope stability concept, we are finding or we are analyze the stability of the slope. The slope which is built by engineered or in hilly areas, we are finding the various type of slope, and to prevent their landslide and erosion, the slope stability is very important key part. Then next one is earthquake engineering. In this branch focused on understanding and focused in earthquake engineering, we are studying or we are understanding focus on understanding and mitigation seismic hazard, design structure and infrastructure that can understand earthquake forces. Earthquake forces are the important in earthquake engineering, and the minimize the seismic hazards. We are studying about earthquake engineering. These key concepts of geotechnical engineering are very important for the study and the understanding purpose of geotechnical engineering. Next one is importance of geotechnical engineering. Firstly, we are study what is geotechnical engineering, then the key concepts, and next one is importance. What is the importance of geotechnical engineering and why we are studying geotechnical engineering in civil engineering? There are many fields in which the geotechnical engineering is used. In this, first one is the safety and stability. In geotechnical engineering, ensure that structures are built on the soil ground and can withstand the forces they will be subjected to. It means the in the point of view of safety and stability, we are also use the geotechnical engineering. Then next one is natural hazard and mitigation. It means in the natural hazardous problem, that is important role of geotechnical engineering. It play a critical role in protecting communities from the natural hazards and like as a earthquake and landslide and the flood by designing the structure and infrastructure to withstand these events. It means in natural hazard like as a earthquake and landsliding, we are used the geotechnical engineering concept and protect our communities from these events. The next one is optimizing earth material. It means geotechnical engineer utilize the earth material effectively for construction project and make sure these material are used safely and effectively. It means in geotechnical engineering, the geo earth material like as a soil, rocks are used effectively and construct safe construction. The next one is a sustainable infrastructure. The next importance of geotechnical engineering is sustainable infrastructure. It contributes to sustainable infrastructure development, ensure that the project are environmentally responsible and meet long-term need. In the point of view of long-term need or sustainability, maintain the sustainability, we are using geotechnical engineering in civil engineering. These are the important importance of geotechnical engineering. The next one is next important or next important part of geotechnical engineering is the finding or the various investigations are used in geotechnical engineering. The geotechnical engineering in which geotechnical site investigations are used. In site investigation, there are four investigations are used for finding out the properties, then their behavior of the soil and the rock. So, for finding out their properties and the properties of soil, the first investigation is used with geotechnical engineering is soil sampling. In soil sampling, geotechnical engineers used various methods like drilling and coring to collect soil sample for laboratory analysis. In laboratory analysis, we are collecting the soil sample from the ground and finding the properties of the soil and the important things what we want to find out. Then next one is in situ testing. In this testing, this test measures soil properties directly in field. In first site investigation, the soil sampling, it means the soil is collected from the ground and test carried out on soil in laboratory. But in next investigation, we are testing or measure the soil property in directly field and providing valuable insight into soil behavior. Then next one is geophysical surveys. In this type or in this investigation, technique like seismic and electric resistivity surveys provide a broad understanding for the subsurface condition and the finding out their main properties of soil and their behavior. Then next one is groundwater monitoring. In groundwater monitoring level and the quality is essential for understanding soil conditions and potential impact on construction project. These are the main investigation carried out in geotechnical engineering. Next is a foundation design. We are study about key concept of geotechnical engineering. In this, we are study about foundation engineering. These are the foundation designs in geotechnical engineering. First one is a shallow foundation, then second deep foundation, bearing capacity and settlement analysis, soil structure interaction. These are the four main components of the design for the foundation. The next one is earth retaining structures. In geotechnical engineering, we are used or we are construct earth retain structures. But what are the earth retain structure and the type of the structures? The first one is the type of retaining wall. The common type include gravity wall, cantilever wall, and shell sheet piles. Each are type of retaining walls, and they are different, they are construct in different type of load or different type of soil which are carried the different type of loads. The next one is design consideration. In earth retaining structure, we are uh, used or we are considered the second concept is design consideration. Key factor includes lateral earth pressure, drainage, and the potential for the soil movement behind the wall. The next one is a reinforced soil structure. The geosynthesis are often used to reinforce soil and improve the for performance of retaining walls. The next one is soil nailing and anchoring. That is, this technique is often to use stability of slope and support excavations. These are the important things for the geotechnical engineering or the study about geotechnical engineering. The next one is geotechnical aspect of transportation. That is, geotechnical engineering is also used in transportation sectors in civil engineering. In transportation sector, there are four main aspects of geotechnical engineering. First one is highway and railway embankments, in which these require careful geotechnical engineering, ensure that the stability drainage and prevent settlement. In highway and railway embankment, geotechnical engineering also used, but it is used for the careful design and stability design of embankment to sustain, or in another word, we also find out the design to ensure stability and drainage and prevent the settlement. The next one is uh, pavement subgrade. The pavement subgrade, the soil beneath the pavement needs to be analyzed and potentially improve the support traffic load. Then next one is bridge abutment and approach structures. Geotechnical considerations are vital in designing these structures to handle the transfer of the load from the bridges to the ground. The transformation of the load from bridges to ground, the geotechnical engineering is used. Then next one is tunnel design. For the tunnel designing, geotechnical experts is used. There are very key concepts for the safe and efficient construction of tunnel in soil and rock formation. These are the geotechnical aspects of transportation. It means geotechnical engineering is also used in transportation engineering. Then next one is environmental geotechnics. The first one is contaminated site assessment. Geotechnical engineer assess the uh, extent and nature of contamination of soil and groundwater, and reduce the contamination of soil and groundwater. The next one is remediation. They develop and implement strategy to clean contaminated soil sites and protecting the human health and the environment. The next one is waste contaminated system. It means waste, or the geotechnical principles are applied to design landfills and tailing dams, ensure the safety or the safe and environmental sound contamination of waste material. It means the geotechnical engineers are geotechnical are engineers are use various techniques to contaminate or to protect, clean up the contaminated site. Then next one is groundwater flow and transport. The analyze the groundwater flow and the movement of contamination to prevent pollution and ensure the protection of water resources. In groundwater flow, engineers are analyze the groundwater flow and they reduce their contamination. The next one is geothermal energy. In geothermal energy, geotechnical engineers play a critical role in design and construction of geothermal energy projects. These are the environmental geotechniques are important geotechnical techniques are used in geotechnical engineering. The next one is the future of geotechnical engineering. We are studying in this lecture. There are different key concept, main definition, and various importance of geotechnical engineering. But what is the future of geotechnical engineering, and why we are studying of geotechnical engineering? The first is the advanced modeling and simulation. by the providing uh, advanced technique, or we are use of we are use various new techniques and modeling and simulation is beginning increase the commonly. It means the various techniques are used of geotechnical engineering in future. Second one is AI and machine learning. Machine learning, AI and machine learning are the big interested in geotechnical analysis and decision making. For the decision making process, we are also use AI techniques. The next one is remote sensing and geo Atl techniques. These techniques provide valuable data for site characterization and analysis. Then next one is climatic change adaptation. The geotechnical engineer are developing the strategy to address the challenges posed by climate change, such as the rising sea level and more extreme weather events. It may These are the future, these are the main concept or main components for analysis, or analysis, or we are also called main key concept for the future of geotechnical engineering. So these are the important and the main part or the basic of geotechnical engineering. So thank you for watching this video. Thank you so much.